Expensive coffee, a special day, and musical taste. Why is making predictions so fun but rarely correct? Do you like making predictions? Do you like thinking about the future? Daydreaming? Do you ever play the lottery? What numbers do you think are going to win? Why? If you're like me, you like thinking about the future. You like making predictions, particularly about yourself. But also, if you're like me, they rarely come true. In this talk, we're going to explore the different sources of our ignorance regarding prediction making. And we're also going to look at 6 different reasons why prediction is so error-prone. On a scale from 0 to 10, where 0 is introverted and 10 is extroverted, where would you place me? Most people who just meet me say that I'm closer to an 10, closer to an extrovert. But would you believe that actually I'm closer to a 0? And the people who know me best, like my wife, my children, and my extended family, would tell you exactly that. Now the question is, why was my granddad so quick to hail his longevity was the result of positive thinking? Why are we so bad at predicting what our psychology professor's musical tastes are? And why do so many people misjudge me as an extrovert? The answer is the power of anecdotes. It's like stereotyping. You know a little bit about someone. That little bit you know may be very superficial, like my age, for instance. And from that, you draw all sorts of inferences, all sorts of conclusions, all sorts of comparisons with others that you know like me. Would you believe that I pay $20 a pound for coffee? Now, granted, it's good coffee. In fact, it's my favorite coffee. It won the National Barista Championship about 10 years ago. That's how good a quality of coffee it is. But is it a good deal? Most people say, no way. When most people hear I pay $20 for a pound of coffee, they look at me sideways. They think I have more money than I have sense. The truth is, I think it's a really good deal. Not when you compare it to inferior coffee, like the kind you see in the grocery store for $5 or $10 a pound. But certainly when you compare it to coffee that's of similar quality, say your local Starbucks, and instead of comparing it to the pound, you compare it to a freshly brewed cup, it appears to be a much better deal. For instance, a bag of coffee this size, brewed at Starbucks, would probably get you between 10, maybe even 20 cups. At $3 a cup on average, that's anywhere from $30 to $60 a pound. So if you buy 30 cups of coffee this year at Starbucks, you've paid upwards of $90 a pound for that coffee. Whereas I've only paid $20 a pound, and I can get anywhere from 20 to 30 cups out of that pound as well. Take a look at the images to the right. Do you recognize these people? I mean, it's obvious they're all white, and they're all men, and they're all at least probably middle age. Maybe a few of them are younger. But do you recognize them? Take a good hard look. Now what I want you to do is turn your head around. That's right. Turn your head so they appear right side up. How did you miss Howie Mandel? How did you miss Bradley Cooper, Donald Trump? Now I'd like you to imagine that you're invited to play poker tonight. It's $5 a hand, Texas Hold'em. You sit at the table, you throw your $5 in the pot, and the dealer immediately takes a fresh pack of cards out of a pack and begins to deal. What do? Do you fold immediately? Do you play and hope for the best? Do you put your experience as a card player to work and try to fake your way to a winning hand? Or do you immediately throw your cards in and say, "Miss deal"? Well, if you're smart, if you've ever played poker, or any card game for that matter, you know that this would be unfair. It would be unfair because the dealer should, before anything, shuffle those cards. And when you're doing research into human behavior, we have to always remember that people come in with all sorts of differences, all sorts of variations. And before we can put them to the test, before we can compare them systematically, before we can look at or examine the extent to which something is working in a psychological experiment, you've got to first shuffle the cards or shuffle the participants. More on that later. Next, I'd like you to do a little calculating. I want you to imagine that you walk into a room of strangers. How many people, including yourself, do you think would need to be in that room before you'd have a 90% chance of ensuring that two of you share the same birthday? Put another way, you walk into a room. Before you can be confident that two of you in that room have the same birthday at 90% confidence, how many people would need to be in that room? Now, here's a little hint. There are 365 unique birthdays in a year. Out of 365 possible birthdays, how many people do you think need to be in a room before at least two of you will share the same birthday at a 90% chance? Would you believe that it's close to 30? 8 people. If you don't believe me, calculate for yourself here. At the end of the game show, I'm not sure if it's still on television, Deal or No Deal, participants, if they're very fortunate, should have 2 suitcases left. They start with, say, 50 suitcases, and they systematically reveal what's inside the ones they pick, leaving only 2 at the very end of the show. Again, if you're fortunate. Now, these suitcases have different amounts of money in them, and the objective is try to leave with as much money as possible. One of these suitcases has $1 million prize. Another suitcase has only $1, for instance. Let's imagine that at the beginning of the game, you, the contestant, selected suitcase 5. After you selected suitcase 5, you were asked to choose 2, 3, 4 suitcases at a time which suitcases you would like the show's host, Howie Mandel, to reveal. So, throughout the game, you revealed every suitcase remaining except 1. Now, you know that the $1 million was not in any of the other 48 suitcases. You're left with just 2. The suitcase you started with, number 5, and the suitcase that remains, number 17. Now, the question is, do you keep the original suitcase? Or do you switch if given the opportunity and take suitcase number 17? Did you know that most people say it doesn't matter? There's a 50-50% chance of winning now, whether I keep suitcase number 5, my original, or I change to number 17. But the truth is, you have a 98% chance of winning the $1 million if you switch to suitcase number 17. To learn more about that, click on the image in the screen. Probability, my friends, is important. Probability is a mathematical function, a mathematical formula that you can learn and practice. And understanding probability. Next, how many keys in your pocket in your purse, on your person right now, crank your car. Or if you don't have a car, open your door. Most people say 1. They can even quickly pull it out and show me. Next, I'll ask a follow-up question. Is that the only key that you have in your possession that will crank your car or open your door? And are you certain that that's the only key that will do it? Most people say, yes, that's the only one that'll do it. And when asked, how do you know that? They'll say, because that's the one I use to open my door or crank my car. But all that really tells you, the only conclusion you can really draw from that is that that is one key that you know will crank your car or open your door. You don't know if that's the only one because you haven't compared it to anything else. In other words, you've started with a conclusion before you've even put alternatives to the test. And speaking of putting things to the test, consider the next example. Should you ever change your first answer on a bubble test? Imagine you take the test, you've got 2 or 3 answers that you decide to erase and change. You get your test back, you notice you've made an 84. What's the first thing you do? Well, the first thing you do is you look at the ones you got wrong. What's the next thing you do? You look at the ones you got wrong to determine whether or not you changed your answer. And yes, oftentimes, you have indeed changed your answer. This makes people believe, unfortunately, that they should never change their answer because they can find instances of when they changed their answer and got it wrong. Before you can draw the conclusion that you should never change your answers from your first inclination, you must do a fair comparison. You must look for counter evidence or alternative evidence. What kind of evidence should you be looking for? Well, at the very least, you should be looking at all of the instances in which you changed your answer. Not just the ones that resulted in a wrong answer, but yes, even the ones that resulted in the right answer. Finally, what should you do before an exam to ensure you're prepared? You've got one coming up on the 18th of September. What should you do? What will you do in anticipation of this exam? If you're like most students, most good students, you'll say, well, I'm going to prepare. I'm going to study. The next question is, why are you going to study? If you're like most, you'll say, because I want to learn. I want to make sure that I'm prepared. I want to make sure I know the material that could be on the test. Does this guarantee you're ready? I would submit to you no. I would submit to you that you're just as ignorant going into the test after you study your notes, after you study the textbook, as you would be really had you never studied to begin with. I know that's an outrageous claim, but let me break it down and explain why I say this. The only thing studying your notes will tell you is that you know something that you know, or that you don't know something that you know. It will not tell you that you don't know something that you don't know. In other words, if you don't have it in your notes, it could still be on the exam. If you're trying to determine what it is you don't know by looking over your notes, that's not going to do it. What should you do before an exam to ensure you're prepared? Take exams. You should take tests and quizzes as part of the process of preparing for exams. You shouldn't wait until the exam to find out what you didn't know. Ignorance of what you don't know is bad for predicting what you should know. Why is prediction so hard? In summary, number one, we talked about anecdotes are compelling, but they're not generalizable. My grandfather lived 5 years and did no medical treatment. But that does not mean that if others were prescribed that same process, they would necessarily live as long as he did. There may have been something special about him that just simply doesn't generalize to others with stage 4 cancer. Number two, we have trouble thinking to scale and perspective. It looks like at first glance, $20 for a pound of coffee is too expensive. That's because you're comparing it to the same scale, another pound of coffee that perhaps might be cheaper. Of course, it might also be of an inferior quality. But comparing it to a cup of good quality coffee that you purchase in a coffee shop, well, at $3 for a 10-ounce cup, $20 a pound is not that much. In fact, it's a deal. We forget to shuffle the deck before we deal. If I had 4 points worth of extra credit to give away, and I was going to give 4 people in the class 1 point each, and I just walked over and I handed 4 people that extra credit, and I handed the rest of the class a piece of paper that said, sorry, there's no more left, you'd say, that's not fair. What you'd expect is if I'm handing out extra credit, I give everybody the same amount, or I give everybody an equal chance of earning it. At the very least, I would need to shuffle those 4 points worth of extra credit and then deal them out so that everyone has the same chance of getting one of those 4. Number 4, we don't understand probability. Math seems hard to us. Probability seems magical. It seems formulaic. It seems intense. That's probably why making predictions that are based upon cold, hard mathematics seems so difficult. The truth is, you don't need that many people in a room before you can be relatively confident, at 90% confident, that 2 of you are going to share the same birthday. That seems illogical and counterintuitive, but that's only because you don't understand probability. Number 5, we start with conclusions instead of questions. This is known as confirmation bias. If you start by saying, I shouldn't change my answer, and then you look for evidence to support that, and only look for evidence that supports that, you're going to be bad at making predictions. Finally, we don't know what we don't know. We are ignorant of what we don't know. Therefore, if you're preparing for a test, you need to be quizzed in advance of that test. You need to be tested in advance of that test so that it can be brought to your attention what you don't know. Because without test questions letting you know what you didn't know, you will remain ignorant. The only thing you'll know is what you know, what you have in your notes. You'll never know what you don't know, and therefore you'll never be able to prepare for that. Okay, that's all for now. I look forward to seeing you next Monday and Wednesday, depending on the cohort you're in. In that class, we will get into the nuts and bolts of the first 2 chapters, starting with this slide. If you want to get a head start, feel free to go into Blackboard and toggle through some of these slides on your own. Okay? Take care and have a good weekend. Bye-bye.